What's up, Algebra 1 students? It's Mr. Ford here with another homework tutorial. Today we're looking at 3.3.2 Part 2, problems 99 through 104, starting off with a bunch of absolute value problems. So let's get into it. Again, these problems are not difficult to do once you realize the pattern. What you have to remember is that you're going to take this inside part of the absolute value, and you're going to kind of write it down twice, I think is the best way. 9 plus 3x equals. Again, I highly recommend you follow any sort of formatting that I'm doing because that'll help you organize your work. Next, you're going to take the number that it equals, 39, and you're going to write it once positive and once negative, and these are the two problems you have to solve. Now, these are a little tougher than the problems we did in the previous set, but they're not too bad still. Start by subtracting 9 from both sides, and I like to do this in both equations, side by side. The 9's cancel out over there and there. You're left with 3x equals 30, and 3x equals negative 48. Careful on those minus negative calculations. Now you're going to divide by 3 on both sides in both equations, and that's going to kind of give you your two answers. X equals 10 over here, and x equals, I have no idea what 48 divided by 3 is, but I think it's a whole number. It's negative 16 over here. There you go. Not too bad. Question B, very similar. Again, I'm going to repeat that pattern again. Take 2x minus 1 and 2x plus 1 equals 2x plus 1 equals. Write it down twice. One of them equals 10, one equals negative 10. That's your outside part right there. Now you're going to work through this minus 1, minus 1, minus 1, minus 1, subtracting 1 from both sides in both equations. The 1's cancel out. You got 2x equals 9, which is not going to be a whole number, and 2x equals negative 11, which is also not a whole number. Divide by 2, divide by 2, divide by 2, divide by 2, and you'll get your two answers. X is equal to 9 over 2, or if you want to be a monster, 4.5. And over here, x will equal negative 5.5. Or, sorry, negative 11 over 2, if you want to be a cool guy. There you go. Question C, you're going to see the same things over and over again. A really common mistake on this is to take that negative sign that I see there and get rid of it, which you actually can't do. You gotta write negative 3x plus 9 exactly how it is, negative 3x plus 9. Absolute value does not get rid of negative signs that are part of the inside problem. 10 and negative 10 go down, just like before. Start by subtracting 9, subtracting 9, subtracting 9, subtracting 9. You're going to get negative 3x equals 1, and negative 3x equals negative 19. Divide by negative 3, divide by negative 3, divide by negative 3, divide by negative 3. Again, I highly recommend you follow my thinking and mapping out this problem. Negative 1/3 is one of the answers. The other answer is whatever 19 over 3 is. I actually have no idea, so I'm not going to worry about it. Question D is that classic trick question which you're going to see on all these sets. You have an absolute value that equals a negative number. This is a no solution. Just watch out for problems like this because I'm going to put them in front of you and see if you can catch it along the way. Okay, next question. 3/100. Find the following products by drawing and labeling a generic rectangle or by using the distributive property. I think the distributive property is the best plan since these are just 1 by 2s. Here you're going to have 5x squared minus 30x. That's honestly all there is to it. Over here you're going to have, let's see, multiply those. For the first part, you're going to have negative 9 times 6, negative 54 times y. And then please be careful here. You got negative times negative. That's going to be a plus. 9 times 3 is 27y squared. And there you go. Okay. For each generic rectangle below, find the dimensions and write each area as a product of the dimensions and as a sum. So we should remember to do both of those things at the end of this problem. Here we're actually working backwards. Similar to what we did yesterday, we're going to need to find the actual dimensions. To do that, you kind of have to think about what's the greatest common factor of these two things you have here. Both of these guys have a 2 and an x, because 2 and 10 are both even numbers, so you got to pull a 2 out, and then x squared and x both have an x. Now, if you go backwards and divide by those things, this would just have to be x there, because 2x times x gives you x squared, and this would have to be 5. It'll be 2 times 5 is 10, and then you'll have 10x. So, as a product, your answer looks like this, 2x times x plus 5. And as a sum, your answer will be 2x squared plus 10x. It's worth mentioning that if you didn't catch the 2 in this problem, you could also write this as x times 2x plus 10. That would also do the trick a little differently. It's not as good, but it's also correct. So question B, again, now we're in the real game. We got to really think about what we would multiply to get these things. The trick, I think, is to start with 2x squared. You need an x and you need an x, but that doesn't account for the 2 that's there. It doesn't really matter where you want to put it. I'm going to put it out here. Actually, it kind of does, because I noticed that 2 does not multiply to make 3. So that would not work. But it does multiply to make 10. So I'm going to put the 2x over here. In fact, I notice that the first question, question A, is actually the same as that top row right there. I think we're meant to see that pattern. 2x squared plus 10x there. So we're going to get the same thing. Actually, now if you divide out the 2x, you'll have a 5 over here. 2x times 5. And now you can divide further and figure out what's going to go in front over here. X times 3 gives you 3x, and 5 times 3 gives you 15. So I think that's the best answer. So again, your product is going to look something like this. You're going to have 2x plus 3 times x plus 5. And your sum is going to be 2x squared plus 13x plus 15. Right there. 3102. Solve each of the following equations. Be sure to show your work carefully and check your answers. So away we go. We're going to start by doing some distributive property in all of these problems. This is going to be 6x minus 8 equals 22. We'll then add 8 to both sides, and we'll get 6x equals 30. And then we'll divide by 6 on both sides, and we'll get x equals 5 for the final answer. Again, x equals 5 on its own will not give you any credit if you just watch this video, and then if you're watching, hopefully you're not watching this video with the sound off, and then you can't hear anything I'm saying anyway. Anyway, over here we're going to have to do this distribution just like before. We're going to have 12x minus 30 equals, and this is also a distribution that I think we should do. We should multiply that negative 1 throughout and get negative x minus 4. That's going to make it easier to work with. I'll start by adding x to both sides and get 13x minus 30 equals negative 4. And then I'll add the 30 to both sides. And that's going to give us 13x equals 26. And we could divide by 13 on both sides to get the answer there. That's going to be x equals 2. Not too bad. Again, look how much work is there. X equals 2 on its own is not enough to be anything. So there's a lot of work that goes into this problem. Question C. Again, there's a minus sign being distributed there, so let's be careful. This is 2 minus y minus 2 equals 3y. What's interesting about this is that the 2's are actually going to cancel out. 2 minus 2 is 0, so you end up with the problem negative y equals 3y, which you can solve right now if you really critically think about it, but let's just keep going. What you're going to do is you're going to add y to both sides, and you're going to get 0 equals 4y. A lot of people will stop here and say no solution, but there absolutely is a solution. If you want to keep going and divide by 4 on both sides, y is 0. That's it. If y was 0, the equation would be true, so that's the solution. And question D, let's do the distribution first. You got to do 4 times x and 4 times 1. So it's 3 plus 4x plus 3 equals 159. We can combine together our 3's to make 6, so we'll have 4x plus 6 equals 159. And if we subtract the 6, we get 4x equals 153. Why a person made such a horrible math problem, I have no idea. But 153 divided by 4, if I pull up my calculator here really quick, is going to be some decimal, 38.25. I don't like that problem because I don't like bulky problems that have weird solutions, but I suppose that's what the answer is, so that's what it's going to be. And then finally we have 2 more problems here still. We're going to do a bunch of multiplying each of the following expressions, and make sure you show all of your work, please. I really think it's a good idea that you stick with the generic rectangle, especially as these get more complicated. X plus 3, 4x plus 5. I'm not going to use them since this is an answer guide. I'm just going to do the distribution in my head. But I am going to show all my work here. For this one, I would have a 4x squared. I would have a 12x. I would have a 5x. And I would have a 15. Again, all I'm doing here is using kind of the generic rectangle that lives in my brain to make sure I get all possible combinations of those 2 things. Of course, the middle 2 can combine together to make 4x squared plus 17x plus 15. Like that. That's the solution. Question B, again, very similar. I'm going to get a negative 6x squared. I'm going to get a negative 12x. I'm going to get a... Oh, whoops, I withdraw. I'm going to have negative 6x to the third power because I have 2 times 1 there. I'm going to have a minus 8x squared and a minus 16x. This is also a 12x squared, I think, if I got that right. Yeah, I'm just checking my work here really quick to make sure I got it. I'm going to have a negative 6x to the third, negative 12x squared, minus 8x squared, and a minus 16x. Yes, these two will combine together, and so the answer is negative 6x to the third minus 20x squared minus 16x, and that is the solution. Question D, another 2 by 2. If I multiply this, I'm going to have a negative 3xy. I'm going to have a plus 3y squared, a plus 8x, and a minus 8y. Again, this is one that I highly recommend you use a generic rectangle if you're not seeing all those combinations. There's a lot of weird positives, negatives in there, a lot of good mixes of different variables, so be careful making sure you get all those combinations. None of this combines together, so that's the answer. That's as good as it gets. If I wanted to be a stickler, I would put the 3y squared in front, followed by the minus 3xy, and then the plus 8x, then the plus minus 8y if I was going to put it in standard form, but it doesn't matter too much. Question D is one you might want to use a rectangle for. I'm going to use one because I always get, once there's more than 2 by 2s, I start to get confused. So we're going to have a y at minus 4, we're going to have a 3x, a 5y, and a minus 2 there. So we're going to have a 3xy, we're going to have a minus 12x, we're going to have a 5y squared, a minus 20y, a minus 2y, and a plus 8 when we're all there. And I only have one set of like terms. Those two are the only ones that will combine together. So we're going to have our 5y squared in front, followed by our plus 3xy, followed by our minus 12x, then our minus 22y, and finally our plus 8. I'm going in standard form there. Decreasing order of variables is what that's called. And 3104, we got what we've been practicing the last couple days, and that's the new stuff where we got to solve an equation for a variable. So let's start with 3104a. We're going to solve this for x. First thing I want to do is add the 5 to both sides, and this will be y plus 5 equals 2x, since they cannot combine in any way. And then I'm going to divide that 2 out, because I just want it gone. And that'll leave me with just the x. So y plus 5 over 2 equals x, and that's how I would leave it. I would not do any more math with that than I have to. Question B, we're solving this for w. It's going to be very similar to the last problem. I'm going to start by subtracting the number off, subtract the 9. It'll be p minus 9 equals negative 3w, and then we'll just divide that negative 3 out. And so we'll have p minus 9 over negative 3 equals w. That is the answer. If you wanted to keep going, I suppose you could divide the 3. You'd have a negative p over 3, and then a plus 3, because 9 divided by 3. But I don't know why you would keep going with that. Just leave it. It's done. Question C is going to ask us to solve this equation for m. So that's going to be a little more complicated, but it's still the same idea. We're going to start by adding 6 to both sides. I guess the only difference is that now 6 has something to combine with on the other side. So you'll have 2m equals 4n plus 10. And then we're going to divide everything by 2. And I actually am going to divide it here because I noticed that both 4 and 10 are even numbers, so they can all divide by 2. So m is going to equal 2n plus 5. And I think that's the bestest answer for that question. And then finally, let's flip over to the last question. We're going to solve this one for y. This is actually really, oh, never mind. We got to combine our y's together. First thing I want to do is gather all the y's together on one side. So I'm going to take this y on the left, and I'm going to add it to both sides in order to move it from the left over to the right. So we'll have 3x on the left, and we'll have a negative y over here. And this is really close to being done. The only difference is that I don't want negative y, I want positive y. So I'm just going to multiply by negative 1. That's the easiest way to make this happen. It'll make it negative 3x and positive y, which is a good way to do that problem too. There you go. Hope you enjoyed this homework tutorial. I'll see you in the next one. You guys are great. Keep it up.